like to invite you to today's webinar, which is all about asking a retinal researcher your questions. And today we're joined by Dr. Lisa Nivison Smith. So Dr. Lisa Nivison Smith is an NHMRC Research Fellow and a Scientia Lecturer from the Centre for Eye Health and the University of New South Wales. Her research specialises in vision science and age-related macular degeneration. She specifically looks at how to use advanced eye imaging technologies to better understand the early stages of AMD, with the ultimate goal of helping to develop management strategies that can be better tailored for individuals at greatest risk of vision loss from AMD. Lisa also collaborates with the UNSW Bionics group, developing the next generation bionic eye implant. Lisa's research has been supported by over $1 million in funding from the NHMRC, the Rebecca Cooper Foundation, and the UNSW Scientia program. She has published 43 papers. Lisa is also a passionate science communicator and Women in Science advocate as part of the UNSW Women Science Champions. So thank you so much, Lisa, for joining us. We're very honoured that you're here.
Thank you, Del. And thank you for that lovely introduction. That is my official biography. But before I start, I'd like to tell you a bit about me and I guess how I got into being a retinal researcher. So I decided to become a scientist because my grandmother was a scientist. She worked at the CSIRO, and she's actually one of the first women to study physics and chemistry at the University of Sydney. But because before then, they didn't think women were capable of studying such subjects. So I actually followed in her footsteps. I also went to the University of Sydney. I graduated with a Bachelor of Science degree in molecular biology and genetics. And I decided I wanted to try a career in research. So I went on to stay at the university and pursue a PhD in the field of tissue engineering. So I graduated with a PhD and found myself not particularly wanting to stay in the field of tissue engineering, but wanting to be a researcher. So I took up sort of the first job that was offered to me, and this was at the University of New South Wales, working at the School of Optometry and Vision Science. So I started working on animal models for retinal diseases, including retinitis pigmentosa. And I got to spend my days looking at beautiful images like this of the retina. And I guess I fell in love with the retina. It's such a beautiful organized structure. And I've been in this field ever since. I've moved slowly over the last couple of years into more clinical research, working at the Centre for Eye Health, also at the UNSW campus, and focusing a lot on the disease macular degeneration and the early stages of this disease, how we can detect it earlier and help prevent people going to that later blinding stage of disease. So I'll hand it over to you, Del.
Yeah, thank you for that, Lisa. It's really great to see how you've got to the point that you are to where you are at the moment. So yes, we'll start the Q&A right now. So first question is, I have dry macular degeneration. Is there any new treatments to help fix this condition?
Yeah, so this is a great question, Del. So I am aware this audience would be quite educated on macular degeneration and probably aware that in the dry form of this disease, which in terms of the number of people it affects is quite large, quite significant. About 90% of people who sort of progress to a stage where they experience vision loss from macular degeneration is due to this form. Currently has no available treatment, and this is a significant issue in our field. Essentially, there are 90% of people who we aren't able to help to the full potential. So in terms of new treatments, one of the considerations is the knowledge we know that there are a number of genetic variants associated with AMD, and particularly genetic variations found in complement proteins in those who have macular degeneration. So for anyone out there who doesn't know what a complement protein is, essentially when you get sick, maybe a virus or a bacteria, you ingest one or catch one, your body needs to mount an immune response to help you get better. So this foreign virus or bacteria enters your body creates these antibodies, which you can see here as these blue forks, to recognize this foreign particle, and then your body's immune cells, these blue cells here, recognize these antibodies, and they mount a response in your body to remove these foreign particles. Now, one of the ways they mount this response is they activate these complement proteins. You can see it as this kind of strange alien-looking molecule here. And what this complement protein does is it activates lots of different pathways in the body, including some cells that are really good at basically recognizing these foreign particles and digesting them and breaking them down into little pieces. So that's what happens in our normal body. The complement proteins are very important in our immune response. What we now know in macular degeneration is that a number of individuals with this disease have mutations in their complement protein, the codes for their complement protein. And what happens is that these mutations seem to create these, get these proteins to be a bit more overactive. They're more active than they should be normally. And one of the theories that we have is that this active complement protein essentially means that the body is sort of primed to mount an immune response, even though there's nothing to necessarily attack. And so what might happen is that this sort of immune response might actually start unintentionally damaging normal healthy tissue, such as the tissue in the retina. So one of the approaches at the moment in terms of treatment is to see if there are ways we can actually eliminate this overactive complement. And the study I'm going to show you here is one that came out at the end of last year from a group in the United States. And they're in a phase 2 stage of clinical trial for an inhibitor of complement proteins known as pegcetacoplan. So I'll show you the main results from their trial that they released at the end of last year. So in this trial, they had individuals with dry AMD. They injected them monthly, every other month, or for some individuals, they gave them a placebo. They then looked at how much growth they had in their disease over time. So in the first 6 months, those who got the placebo had about a 0.17 millimeter growth. So that's the normal rate of growth. Those who got the drug, whether it was every other month or monthly, had a reduction in how quickly their disease was growing. You can see here that with the drug, it was reduced to about 0.159 or 156 when you had it more often. But when we do statistical analysis on this, we find that this difference is what we call non-significant. That means that the difference that we see is not great enough to be sure that it's not just by chance that these individuals have a slightly less amount and it's just within sort of error limits. The good news is when they kept monitoring after between 6 to 12 months, they again found the same level of growth in those receiving the placebo, but in those receiving the drug, there was a significant reduction in the growth of their disease. And you can see here, so slightly greater when you had more regular injections. And so this was very exciting results, quite promising for this drug, and that's led it to move on to the next stage, what we call phase 3 of a clinical trial. And phase 3 is the last stage of a clinical trial before you then go for approval for therapeutic use out in the public. So I think this is something we can keep an eye on in terms of the space for treatment for dry AMD.
I think that's really great, Lisa, to see that there was quite a significant change there in that 6 to 12-month period. So very promising. Mm. So we'll move on to the next question. Are there any potential new treatments for wet AMD?
Yeah, so wet AMD, I guess, is a little bit different in the fact that we do actually have a treatment available. We have a treatment known as anti-VEGF. We know that the molecule VEGF is responsible for creating the new blood vessels that we see in wet AMD, and injections of anti-VEGF can quell this particular hormone and reduce this and reduce the loss of vision associated with these new vessels. So I guess before we consider if there are new treatments, it's really important as researchers to question how well the current treatment is going. I guess, you know, to put it bluntly, if it ain't broke, why fix it? And so I'll point you to this paper that was recently published, again, about the end of last year was when it was released. And this was commissioned by the World Health Organization to understand the impact of blindness currently around the world. And so the World Health Organization commissions these kinds of studies regularly to understand the burden of disease globally and then create health advice accordingly. So in this particular study, there was a lot of different diseases assessed, but if we just look at macular degeneration, you can see there's a lot of columns here. If we look specifically at Australia, you can see here that there is 25% less people going blind from macular degeneration than there was 30 years ago. And this very well coincides with the sort of advent of these anti-VEGF injections. And so I think that's a really, really positive thing to take from what we currently have, that we do have a treatment that is actually having an effective, having a positive effect on a population of people. And I think really to highlight why this is important, if you look in this study at some other diseases that cause macular disease, such as diabetic retinopathy, you can see that this trend of sort of reduced vision over time is not common in other diseases. And so I think in that case, we should be quite happy with the progress we have made. That being said, there's always room for improvement. And so in terms of new treatments for wet AMD, I thought I'd point out a very, very recent study that just came out. And that study is looking at addressing the issue that we currently treat wet AMD with multiple injections. The anti-VEGF that we inject doesn't, I guess, last, or it requires multiple doses. And this is costly in many ways. It's costly basically on money circumstances, monetary, but it's also costly in terms of time for the patients, the clinicians. It's costly in terms of the burden of this actual procedure on the emotional well-being of individuals. And so one of the attempts when it comes to making new treatments is to perhaps use the same concept, this idea of, you know, reducing the effect of VEGF, but doing it in a way that is not so invasive and not requiring so many injections. And so the big question we have in our new treatments is, can we reduce the number of injections? And this study that came out just in January this year is looking at a particular gene therapy approach to do that. So this study is in mice, so it is still quite a way off in terms of being an actual therapy for human patients. But I still think it's really important to look at, because this could be sort of the reality in the next 10 years. So in this treatment, what the researchers did was they took advantage of the fact that within our bodies, when we make hormones such as VEGF, we often have to produce them from our DNA. And when we produce them from our DNA, we make a copy called RNA. The thing about RNA is it looks very much like DNA, which you can see on the screen here, but it actually only has a single strand. If you were to make another strand of RNA and they combine, you can actually just nullify that RNA and it won't produce the hormone. And so that's what these researchers did. They made RNA copies of VEGF in the idea that this is essentially the same as nullifying VEGF and being an anti-VEGF treatment. So they created these gene therapy constructs. They injected them into mice, a placebo injection in one eye and a gene therapy injection in the other. And then because mice don't develop macular degeneration as humans do, they induced it by using a laser. So these are the results that they found. On the left-hand side are the eyes that weren't treated with gene therapy, and the right-hand side are the eyes that were treated. And if you look at the size of these circles, which represent how much damage there has been from new blood vessels, from wet AMD, and when the researchers measured this,
sorry, Lisa. Yeah. I think your internet just cut out for a moment there. If you could just go back about 10 seconds, we just lost you for a moment.
Yeah, sure. So I'll just go back and just repeat the results of that study. So as I said, on the left-hand side, we have the example of the eyes that didn't receive gene therapy, and the right-hand side are the eyes that did receive gene therapy. And if you look at the size of these circles and in between the two eyes, you can see that those that didn't receive gene therapy have a lot larger circles with more red blood vessel formation in them than those that were treated with the gene therapy. In fact, when they quantified it numerically, they found there was a 63% reduction in how much wet AMD was affected in the eyes with gene therapy. The exciting thing about this, though, is they've only given a single injection to these mice, and they were able to get a 63% reduction. So there's a huge potential here that we can create a treatment that almost follows a very similar concept, but reduces the number of injections and the burden.
I think that's incredible. I think a lot of patients, always talk about how they have to receive so many injections for wet AMD. I think that would be incredible if it's, taken down to one or maybe even a couple. That would be, incredible to see. So definitely looking out for that one for the future. All right, moving on to the next question. Is there any research to suggest eye injections will become a thing of the past? I think a very good follow-up question here.
Yeah, definitely. And of course, that would be, I guess, one of the greatest goals, to create a treatment that requires no eye injections. So to answer this question is a little difficult because recently in terms of work, I wanted to present something that was sort of, I guess, relatively applicable. So what I would present is one of the issues we have with macular degeneration that I guess is not always well understood or well described to people with the disease. So if you develop wet AMD, the traditional route is to have anti-VEGF injections delivered to that eye that has wet AMD. One of the issues that occurs, though, is that in around 20% of individuals, they will develop wet AMD in the other eye within the next 2 years. So we often call this the fellow eye. This is a really big issue, because if something were to happen in that first eye, we often sort of think about the second eye being the good eye, the eye that's going to sort of, help get patients get through. So the notion that there is 20% of individuals who are going to potentially have that eye experience the same disease is significant. And there is a lot of discussion about what we can do about this, what we can do with this knowledge. So one of the thoughts is that we should proactively treat the second eye now. Even though it hasn't got disease, we know that it might develop disease. So why not also give the anti-VEGF injections to this eye now and hopefully protect it? The problem with that theory is that 80% of people are going to get unnecessary injections. And as the question says, how can we make injections a thing of the past, not deliver more? So to answer this, I guess that the biggest question is there a way we can predict whose second eye will get wet AMD? And to this, I want to present you with a study that, again, came out in 2020. This is a really interesting study because this study was a collaboration between retinal researchers such as myself, ophthalmologists working in clinics, doing these wet AMD injections, and also computer scientists. And they worked together to see if they could use artificial intelligence, in particular the deep learning algorithm of artificial intelligence, to make this prediction. If we gave this system enough information, could it help predict this and help us identify this 20% population? So what they did was they looked at individuals who had wet AMD in one of their eyes. So here they've named them EX AMD or exudative AMD, which is another term for it. And they followed their second eye, their fellow eye, which didn't have wet AMD. So they followed it by taking images. So they would have images like this. So this is at the start of the study. There's no EX AMD or wet AMD in these patients. And as they follow this eye, here's a picture after 5 months, there's nothing happening. After 8 months, this patient still has a good second eye. But at 11 months, unfortunately for this patient, they are within that 20% group and they did develop wet AMD. And so at 13 months, the injection started in their second eye. So what the computer scientists did was they took these images from thousands of patients, and they tried to build a computer model to guess if this was going to happen. So they created a timeline in their computer model. So here it is in number of months. And they created a predictive number, I guess an arbitrary number, which you can see on the left. And then they said they set their model's parameters. They said the model at time 0 should give us sort of a value around 0. There is no chance that this person has wet AMD in this eye. But by that 11-month mark, there should definitely be a prediction that this eye has wet AMD because the data clearly shows that's what happened. In fact, they challenged their system even more. They said, I don't want to know at 11 months. That's too late. What I really want to know is I need to know about 6 months beforehand that this person is going to convert to wet AMD so that we can be sure to follow and help this person more closely than someone who's not at risk, that 80% who aren't going to have this problem. So they set a level for their algorithm. So basically, if their algorithm's value goes above this blue line, the algorithm is saying that this person will get wet AMD in that second eye. And then they tested it. So you can see here at 0 months, they get a value near 0, so that's good. In the first few months, they still get values below that blue line. So the system is still predicting no wet AMD yet, which is good. We get into that 6-month zone and it's still below that blue line. So the algorithm still thinks that this patient won't get wet AMD. Now, we know that's not true, but the system isn't able to predict it just yet. But once we get to 3 to 4 months before they actually develop it, you can see that this line goes above that blue line. Their system, their artificial intelligence system is able to predict it, and it definitely gets it right by the time it converts. And so this is quite exciting because perhaps we can use these kind of artificial intelligence tools in clinics to help ophthalmologists predict those who may need to come back, you know, for an appointment in the next month rather than 2 months. And those that aren't at risk can wait and they don't have to see the ophthalmologist for another, 3, 4, 5, 6 months. Imagine how useful this could be in terms of scheduling, making sure the people who need appointments get them on time and those who don't need those unnecessary appointments aren't there. And more importantly, that we're not just injecting everybody for the sake of injecting. So I think this is a really exciting space and it's happening all across medicine.
And I think that's great that if we are able to predict it beforehand, it means that maybe we can save as much sight as we can in that fellow eye as well. So I think that, yeah, that would be incredible if that's done. All right, moving on to the next question. Has research uncovered any major risk factors that result in high incidence of macular degeneration?
Yeah, so I guess this question is kind of going back to the beginning. Again, I'm sure this audience is very well educated in the risk factors for AMD. There are, I guess, 3 very big ones that are commonly reiterated: age, family history, and a history or a current smoking. And in fact, I know the MDFA Foundation even have these risk factors within their Check My Macular risk analysis tool, this sort of 5-question, 1-minute tool. So these are very well established. They're very strongly linked with a higher risk of macular degeneration. But in terms of new factors, I know all the work that I've been showing you has been very recent, basically, stuff that has come out last year or even first thing this year. But I actually, in this question, I think I want to sort of take you back to some work that was done. This paper came out in the year 2000, so almost 21 years ago now. And one of the factors that might be one of the risk factors that we might have discovered is called dark adaptation. So dark adaptation is your ability to go from somewhere very bright to somewhere very dark and be able to see again. So your ability to dark adapt. So kind of examples of this are when you're sitting inside your living room and you are watching your brightly lit TV and the lights are on, and you realize you need to go and put the bins out. And so you go outside and it's dark and maybe there's a little street lamp on and that's it. And you've got to sort of fumble around and, get your bin to the curb. And so your eyes have to adapt to that darkness. So your ability to do that is your how well you dark adapt. The other example I usually give, which unfortunately is maybe not quite relevant in our COVID era times, is when you go to the cinema. So you're walking around in the brightly lit foyer, and then you get to the theater and you walk in and it's dark and you're trying to read your ticket and you're trying to get to your seat, and it's quite a difficult task. And so your ability to sort of adapt to that darkness is dark adaptation. So in this study, as I said, almost 21 years ago, they took individuals who were sort of older but had healthy eyes and those who had the early signs of AMD. And they looked at their ability to do this, to dark adapt, to go and see from a bright light to a dark light circumstance. And I'm just going to show you this very, very simple part of this graph. Basically, what they found is, those who are normal have a normal ability to dark adapt, but those who had early AMD have much reduced ability to dark adapt. They have trouble doing these particular activities. And so this was a really exciting finding. This was explored more by this group. And in fact, what they did was they actually went and looked at a group of older people and measured their dark adaptation ability. And then they monitored them 3 years later and checked whether they developed AMD or not. And what they found was those that they measured that had originally had a poorer ability to dark adapt were twice as likely to develop AMD. And so we really think that maybe this dark adaptation ability could be a way to flag people at risk of developing AMD. It could be another risk factor we could add into a calculator. Unfortunately, it's not quite as simple as that. So for example, there are a group of individuals who don't show this effect. So these are people who have AMD who have essentially normal dark adaptation. So that does complicate things. And dark adaptation is not that easy to measure. You do require an instrument. It costs money. It's not common in optometric practices. And so it has been a very long time for this work to translate. And it's finally, at the end of last year, it's it's part of a clinical trial called the All-Star clinical trial that's being run in Alabama to see how effective it can be as a risk factor. So going ahead, maybe this might be introduced into our space. As I said, it's a interesting one because it looks very powerful, but logistically to get it into clinical practice has been very hard. And in fact, it sort of wants me to, I'm just going to sort of diverge a little bit into what some of the research I do. So in our group, one of the questions we asked is, with this powerful knowledge that there is this change in people's ability, functional ability in AMD, can we kind of measure this just with the technology we already have in optometrists and ophthalmologists' offices? Why do we need to buy new equipment and why can't we use what we've got? And so we looked to see if we could adapt what we call this machine here, which is a visual field machine. You might have done this when you've gone to an optometrist or an ophthalmologist. You stick your head in a bowl and lights flash and you press a button every time you see lights, and it lets us see how, I guess, get an idea of what you can see. And so we asked, can we just modify this to measure these changes? And we published this in 2019, and what we found was that indeed, yes, if you have normal people here at 0, those with AMD do show a difference when you measure it with this device that's very commonplace in optometry and ophthalmology. And in fact, when we used a very specific kind of analysis that we developed, we found you could need a bigger difference, so it'd be even easier to measure. And so we're currently working on sort of developing this maybe into a tool we can actually more quickly implement and actually put into practice for patients.
How amazing would that be, Lisa, if someone could just walk into their standard optometrist and they can check their dark and light adaptation there as well? That'd be amazing. So we'll go on to the next question. As we age, what signs are we looking for that are related to macular disease?
Yeah, so again, a good question. Really interesting for me because this is sort of the early stages of disease, which is the focus of my research. So I guess for most of you who've ever either you've been diagnosed with macular degeneration or you know someone who's been diagnosed with it, the sort of hallmark kind of sign that people talk about, particularly in the early stages, are drusen. So drusen are these yellow fatty deposits that we can see in the center of the retina. It's the kind of telltale sign of the starts of macular degeneration. And the very exciting thing, I guess, for us is that over the last 10, 20 years, there's been an explosion in the amount of devices and equipment that we can use to take photos and to image the retina in different ways. And so to the point now where we don't just have to look at the retina kind of face on or on fast, as we call it, flat, on flat. We can even sort of, I guess, look through it cross-sectionally, almost like cutting a cake. And we can see these drusen now for the little sort of mounds of sort of fat that they are, I guess, and other things. And you can see them here in this picture, as this is a picture of the retina sliced through, and you can see them here in what we call the outer retina. So this is the part of the retina that actually detects light in your eye. So I guess with all this technology, the question is there any other signs that we can look for besides drusen in these early stages? And in my research, one of the things we've asked is, what about the rest of the retina? Traditionally, it's not really been studied or considered, partly because we couldn't take a picture of it, but also because there's not these obvious, lumpy changes in this part of the retina. That doesn't mean that there's not changes there that we haven't looked for. So our group had a look at these layers. We looked at the thickness of these different parts of these layers, and what we found was that in macular degeneration, there is changes in the early stages. So we published this just last year, and if I just show you the main results of the paper, when we looked at the very center of the retina, we found that the thickness of a layer called the ganglion cell layer, so this is the layer that actually takes the information from the outer retina and actually processes it and then takes it all the way up to your brain so that you can see an image. This layer is thinner than in those with early or intermediate AMD versus people of the same age who have normal healthy eyes. The really interesting thing is if you look at other parts of the retina, if you look at other parts of the retina, so if you look a little bit further out, we see the opposite effect. So now, in comparison to those with normal healthy eyes, those with AMD had a thicker ganglion cell layer. And so this is really quite exciting because no one's ever actually seen or even looked at this before. And these changes could be measured at the same time that we measure drusen. And so we're currently working on seeing if we can actually kind of connect the dots, if you will. Is there changes here that we can put together to make a better picture of what the early stages of macular degeneration look like, and how we can maybe hopefully even figure out who's at more risk of their disease getting worse really quickly versus those who are maybe going to have a fairly stable disease for many years. The other thing that we are doing is, as I said, when we're looking for signs for macular degeneration, it's having all this technology means that there is all this new information we can look at. You know, optometrists and ophthalmologists can get all these kind of images of your eye, but then trying to make sense of all that is really hard. And looking for a really unique sign or pattern that will help you help a patient with macular degeneration is incredibly difficult. I mean, you know, computationally, the eye, sort of, I guess, pardon the pun, but the eye can only, you know, the human eye can only do so much. So one of the things that we've been doing in our lab is looking at ways to kind of automate and computerize this to make it easier. So we've been using we've actually adapted a program that's used in satellite imaging to kind of combine these multiple images into just a single color-coded image that highlights the areas that are really important to look at for an optometrist or an ophthalmologist, and the areas that are not so important. And hopefully with sort of technology like this, we can actually kind of identify really unique signs much more quickly, because we're not sort of bogged down by kind of the overload of technology and information. And so we're currently working on this to kind of identify some new signs as well.
I think that's yet another way where we can sort of help people identify the condition earlier and yet save even more vision. And moving on to the next question, is there any research that I can get involved in?
Yeah, so this is a great question for me. So definitely I would point to our research group. As Del introduced, I work at the Centre for Eye Health. It is a clinic on the campus of UNSW in Randwick, New South Wales. We have a number of studies that are running at any one time that people may be eligible to participate in. And so you can always call us. You can either call on the number on screen, that's 0281150700. Or you can email me and I can always forward you any information for studies that would be relevant for you or someone who is interested. And my email address is on screen. It's just my name, l.nivison-smith@unsw.edu.au. Also, if you happen to be within the social media space and you're interested in keeping up with my research, I do put information up on both Facebook and Twitter. If you're interested in following me, I've put the handles there. Otherwise, we do also work with the MDFA to advertise for specific studies which we think would be very important or relevant to their client base. So I'd also look out for that as well.
Definitely. And yes, so if anyone is interested in participating in studies and you're able to get to UNSW, please do contact Lisa. If not, you can contact us as well. If you're interested in studies, but you're not able to get there, or maybe you're not in New South Wales, there are a few other research organisations as well. So just contact the foundation and we'll give you a bit more information. So thank you so much for that, Lisa. That was really fascinating. It's so interesting to see all the newest research coming in and to see what sort of treatments and technology is going to be used in the future. So thank you so much for that. All right, so just moving on, I'm just going to give a bit of a reminder to everybody on how you can ask some questions if you do have them. So like I said before, there should be a grey panel on the right of your screen, and the fourth icon will be a question mark inside a little speech bubble. So just click on that, and then in the white rectangle that appears, type in your question and select send. If you could keep those questions quite general in nature, that would be really great. We won't be able to answer anything that's clinical or extremely specific. If you're not able to put the question in, just call our helpline. That's 1-800-111-709, and we can take your question there. Now, before I go on, I do quickly want to talk about the Macular Disease Foundation Australia and how we try to reduce the incidence and impact of macular disease. So we try to do this through our 4 pillars, the first being prevention and early detection. We provide accurate, current and ongoing information about macular diseases to the community. Last year, we reached over 7,000 people, which we were quite proud of. Secondly, support and services. I'll touch on this a little bit later again, but generally we try to provide support for the entire macular disease community. And thirdly, being the voice of the macular disease community. So it's our privilege to advocate on behalf of the community to state and federal governments, trying to put in policies and making sure that things such as Medicare benefits are not cut. And finally, research and data. So we have donated over $4.1 million to 21 different research projects. We actually have a research grants program happening this year as well, which should be very exciting. Now, speaking of donations, I actually do have another guest here with me today. Her name is also Lisa, and she's going to be taking us through a couple of the marketing things that we do. She's part of our marketing team at MDFA. So thank you so much, Lisa, for joining us, and excited to hear what you have to say.
Hi, everyone. So I will briefly introduce myself. My name is Lisa Ziegler. I'm the fundraising manager at MDFA. And I just wanted to take this time to have a quick chat to you about if you have supported us, how that support has helped our work. And if it's not something that you're doing just yet, you know, why your support is so important to us. So while MDFA has access to some government grant funding, applying for and being a successful recipient of these funds is competitive and can often be quite difficult. As such, we rely heavily on the generosity of everyday Australians to enable us to continue to empower the macular disease community well into the future. Fundraising also allows us to support talented researchers to continue their life-changing work. And as an example, even today's webinar is made possible through the generous donations of our supporters. Put simply, we could not do what we do. We couldn't fulfill our purpose without our community. And our purpose is to reduce the incidence and impact of macular disease in Australia through our 4 pillars of work, which I know Dil just touched on. I'll just go through them really quickly. So prevention and early detection, supports and services, being the voice of the MDFA, the MD community through our advocacy work, and research and data. So we've translated research to support knowledge base for better patient outcomes. So I'll just briefly go through support and services. So our national helpline could not exist without our generous supporters. Receiving donations allows us to continue to provide advice, guidance and information to people living with macular disease at every stage of their journey. Jan Francis, who you can see on the screen now, is someone who can testify to how beneficial it is to have the MD community to have these services available. So Jan is an award-winning artist. She's from Victoria and she was diagnosed with AMD in her right eye in 2016. As an artist, you can imagine that she was worried that it would affect her passion for painting. But after calling through to our helpline, Jan was given all the reassurance and knowledge needed to feel much more comfortable about her diagnosis and upcoming treatment. So it's so important that we can continue to provide this support. Now, of course, we understand that it may not be possible for you to donate today. And for those of you who are thinking longer term and wanting to leave a lasting legacy, a bequest is a great way to do this. Every gift in a will received by MDFA allows us a considerable degree of flexibility and security in planning for the future so that we can continue to support our community and talented researchers. Of course, we know that family members and loved ones come first, and so we encourage you to discuss this decision with your family members before you go ahead and make any changes to your will. So for more information on how you can support MDFA or how you can give us a donation, whether that be a one-off donation today or something, you know, a lasting legacy like a bequest, feel free to visit our website, which is on the screen right now. You could also call our hotline or helpline rather, and one of our lovely employees will be more than happy to help you with that. That's all from me. Thank you so much, Dill. It was a really interesting seminar that I watched today, so well done to the team, and thank you everybody for your support.
Thanks so much for that, Lisa, and thank you for letting everybody know about how we can they can support the Macular Disease Foundation. And I want to quickly talk about how the Macular Disease Foundation can help you. And how we can do that is if you call our helpline number. So this number, the 1-800-111-709 number, that's not just for fixing IT issues for the webinars, but if you have any other questions, so say about AMD, diabetic eye disease, maybe a different kind of macular disease, or maybe you have questions about Medicare, rebates, or even my aged care, or about low vision aids and technology, we can answer all of those questions. If not, we can also provide you access to other support services. If you prefer to email us instead, you can definitely do that as well. You can email us at education@mdfoundation.com.au, and you can also find a whole host of information on our website too, which is www.mdfoundation.com.au. Now, at the end of this webinar, you will be receiving an email. Now, that email will contain a couple of links. So the first link will be to a feedback survey. So this survey is a couple of questions and gives us some feedback on how we can improve our webinars, and you can tell us if there's anything that you liked or disliked about the webinar. We're always looking to improve, so we'd really appreciate it if you could fill that out. You'll also receive a link to a recording of this webinar. So if there's something that you'd like to watch over again, or perhaps you want a friend or family member to watch this webinar, you receive a link to that recording. And you'll also receive a link to sign up for future webinars as well. And speaking of future webinars, our next one is actually going to be next week on Thursday, on the 18th of February. It's going to be all about breaking down depression, and it's going to be presented by the Black Dog Institute. So again, that will be on the 18th of February on the Thursday from 2 to 3 p.m. Now, it seems as though we have quite a few questions coming in. So I might just get Lisa, Dr. Lisa, to come back on the screen, and we'll go through some of those questions. All right, so the first question is, it says, my question is on the factors that cause age-related macular degeneration to worsen once it has started. I have read that science tends to favour inflammatory and oxidative drivers. I'd love to hear your comments.
Yeah, sure. So definitely one of the major concepts around the development and the pathogenesis of macular degeneration is that it is a disease. That involves, I guess, an overactive inflammatory response. So one of the particular issues with the retina is it's a very highly metabolically active tissue. It's working all the time in order to allow us to see. And that comes with consequences. When you have a highly metabolically active tissue, you have an environment that has high levels of oxygen, high numbers of oxidative reactions, and that leads to a greater chance of oxidative sort of stress and damage from that, and this can then initiate immune responses. I guess this is also coupled with theories relating to the genetics of this disease, and that some individuals are more susceptible because they have genetic variants that also have changes in their immune proteins that are not for their benefit. So that's definitely in terms of how the disease develops. In terms of the progression of the disease, there is, again, yes, this concept that it is, I guess, like a sort of a rolling stone, that once there is sort of an initiation of these processes, that they actually sort of escalate and sort of that we get a sort of an increasing or an exponential growth, that that once these immune cells become active, they activate more and more, and we get this growth. So I definitely think that this is a very strong hypothesis. I think that there are still several missing links when it comes to really fully understanding the pathogenesis of this disease. There is a number of variants and changes found in those with macular degeneration that cannot fully be explained by simply this mechanism. And it's what makes it so difficult when it comes to doing research in this disease, is connecting those links. So yeah, I definitely am a strong believer in this hypothesis, but I don't think it's complete just yet.
Right. So the next question, I think a couple of people have asked this. So what is the percentage of patients that progress from dry to wet AMD, and can AI be used in people to predict this progression? So whether that dry will go to wet?
Yeah, this is a very difficult question, because it turns out it's not as simple to predict those who are going to go from, I guess, dry in terms of like the intermediate sort of stage, where I guess you're essentially not really experiencing any vision loss per se, to that wet AMD stage. So we currently have we do have some predictive models that indicate that if you look at risk factors such as Druzen or other changes in the retina, they can give you a percentage chance of how likely someone is to progress to that late stage. So we typically use these as sort of rough guides in clinic. So the most common one is to use both the sort of the size of drusen that someone has, as well as the presence of what we call pigmentary changes. So this is changes, I guess, almost essentially in the pigment color of the retina. So if you have a lot of these changes, the chances, I guess, the chances that you'll progress to this later stage is higher. And so knowing this, there is a number of computer scientists working to essentially feed their algorithms this information to predict this rate or predict it better. So there's a number of studies that have come out recently that sort of say, we can predict this great, but none of the studies essentially can predict any better necessarily than we can at the moment. Right. So the concept at the moment is that we develop these systems as an aid to flag those who are at high risk versus low risk. So we're never able to actually predict that, yes, you'll definitely be progressing the disease, or no, you won't. But we can at least have a better concept of how much risk you're at. And then we tailor the management plans to that risk. So those at high risk get the highest level of review and intervention. And those at low risk are not burdened by this same level of kind of care. And I think that is very important in terms of a global healthcare system, ensuring that, I guess, all people with AMD get a fairer chance. So yeah, so I don't know that we're necessarily ever going to be able to definitely predict it, but I think we will definitely get to a stage where we are much better at triaging people into the appropriate management. Yeah.
Yeah, I think that would be a very valuable tool to be able to know sort of who's at high risk and who's at lower risk, and you know, treat them accordingly. Are there any current clinical trials, so other than the ones you've spoken about, so any current clinical trials for AMD which you think are worth keeping an eye on? Excusing the pun there.
Oh gosh, there is a number. There is a number of clinical trials at different stages. I must say it's a little bit difficult for me to speak to any one of them at the moment, particularly, I guess, relating to the fact that a lot of these trials are run in the US, and so the sort of the progress of these trials are, in some cases, somewhat halted or are altered. I think definitely there are some really interesting trials relating to new sort of or varied versions of anti-VEGF that I think are going to be very interesting and maybe very relevant over the next couple of years. I think the MDFA Foundation actually have kind of their finger on the pulse in this area. And I think there are a couple of treatments for dry AMD. As I spoke to one today, I think there's one or two others that kind of look at this kind of sort of modification of sort of immune or anti-inflammatories that are worth looking at. But I couldn't speak to any one that I think is like a winner necessarily. Yeah. There's also a very large number of trials that look at various nutritional kind of interventions as well. I think they're very interesting, those ones, because they're, again, something that can be hopefully applied quite quickly if they are actually shown to be successful.
Yeah, and as you mentioned, at the foundation, we do definitely try to keep on top of some of the latest research. For those of you that are part of the foundation who are watching along today, you will receive a newsletter every couple of months. I'm sorry, about 3 newsletters a year, and that will keep you up to date with the latest research, with our November newsletter actually having a whole research update in the middle of it. If you would like to receive that, just give us a call and we can send that out to you. It's free, but that does keep you sort of up to date with some of the latest research and some of the most promising bits of research as well. So we'll move on to the next question. This might be the last question that we have time for. Is there any update on the research into stem cells or stem cell treatment?
Yeah, so definitely, I think, I guess for anyone who's kind of not familiar with what this question is asking, we know that in macular degeneration in a number of individuals, they experience geographic atrophy. So this is essentially the death of parts of their retina, particularly their photoreceptor cells, which are the cells that actually detect light. So without those cells, you're not detecting light, you can't see. And also the what we call the RPE, or the retinal pigment epithelial cells. So these are essentially like kind of the supporter cells of photoreceptors. So without either of these cells, essentially you don't have vision. So the concept of stem cells is that stem cells are cells that have not quite decided what they want to be yet, and that's very unique. Most cells in your body have decided what they want to be. I'm a skin cell, I'm an eye cell, I'm a heart cell. Stem cells haven't decided, so the concept here is maybe you can convince them to become photoreceptor cells or RPE cells. You can then put these in to replace those cells that have been lost. So there's been a significant amount of work in animal models showing that this can successfully be done. So we can essentially, I guess, sort of transform these cells into photoreceptor-like or RPE-like cells that seem to kind of look and smell like those type of cells. We can put them into animals that have areas with eyes that are damaged, retinas that are missing these cells, and these cells will go in there and they're alive and they integrate. One of the biggest difficulties we're having, though, is actually getting these cells to function. So essentially, we've sort of, you know, we have our car with no engine. We've built the engine. It works outside. It's all running, and we put it in the car, and we just quite, in terms of getting all the wiring right and getting it to actually start the whole car to work again, is proving to be quite challenging. And this seems to happen in a lot of different approaches we have when it comes to restoring vision. So whether it be through stem cells, whether it be through implants like bionic eye implants, where you use, I guess, a sort of a computerized approach to replace that. It turns out that that sort of circuitry within the retina, that the connections between the cell that tell each other the information to then send it to your brain is incredibly complex, and in disease actually, you know, changes. And so it becomes very hard, even if you replace the things that are missing, to actually get them to talk correctly to everything else that's still in the retina and send a useful and valuable kind of input to the brain to allow you to get a vision. So at the moment, that's kind of the biggest area of focus, is how do we create, we've gotten past the stage of actually creating or proving that concept of creating, you know, stem cells that can replace the cells that are missing. How do we ensure that these cells actually function? So that's where I would say is kind of where the field is at the moment.
So again, very interesting to see the leaps and bounds that research takes in the future. So I think that brings us to the end of today's webinar. Thank you so much, Lisa, for being here today. Everything that you took us through was extremely fascinating, and I, for one, learned a lot, and I'm sure everybody listening in did as well. So thank you so much for being here.
Thank you. No, thank you for having me.
Oh, of course, thank you. And for everybody else, thank you so much for joining us. If you would like to join us for the next webinar, like I said, you can join with that link that we're going to send you, or you can scan the QR code. And we'll hopefully see you all next time. Thank you so much. Bye, everybody.